Hey everyone, good morning, good afternoon, good evening, good night, depending on where and when you're viewing this. My name is Richard Solomon, and I'm bringing you another installment in these PhD Chronicles. About, I don't know, maybe maybe about 3 months ago, maybe four, an association of HR professionals asked me to do a presentation for a webinar they were having entitled Psychometric Testing is Science. And I wanted to use some components of my presentation for these PhD Chronicles to talk a little bit about what I'm doing and how it is, in fact, science. So, to put it in context, let's start with what is psychometrics. So, the field of psychometrics is it's concerned with, or it is a scientific discipline concerned with the building of us or the creation, the construction of assessment tools, measurement instruments, and formalized models that serve to connect observable phenomenon to theoretical attributes. Let me tell you what that means. So, observable phenomenon might be, for example, how someone responds to a questionnaire or a personality or behavioral style assessment set of questions. And then the theoretical attributes might be their behavior. So if they respond in a particular way, we know that people who respond in this way tend to gather data in a certain way, interact with others in another way, prefer certain kinds of work environments, like their information organized in a certain way, and so on. And as you would appreciate, if you gather this data from millions and millions of people, after a while, you can see a pattern emerging. The field of psychometrics is credited to Sir Francis Galton. He's the founder of the field. And he was a statistician, a sociologist, a psychologist, and an anthropologist. So you can see why he would put something like this together. The word itself comes from two Greek words, psych and metrikos, meaning mind or mental, psych, and then metrikos, meaning standard of measurement. So together they are, or they mean the science, or it is the science of measuring mental faculties. All right. So the topic was this that psychometric testing is science. And if we look at what a psychometric test is, it's a standard and a scientific method used to measure individuals' mental capabilities and behavioral styles. Right? So they're evaluation tools used to objectively measure or assess a person's psychological attributes. Remember what we said. So observable phenomenon are we connected to theoretical attributes. So if you respond a particular way, then it tells us something about your preferences. And that's the word we like to use, preferences. So there are all kinds. You can look at aptitude, memory. We can do other psych evaluations, mental illness, those kinds of things. But the area that I focus on, and I'm going to be focusing on part of this, I'll be focusing on for my PhD work, is behavioral styles. Now, behavioral styles is a branch, or behavior is a branch of personality. It's not the whole of it, but it's a branch of personality. So I'll be looking at behavioral styles. And there are a number of psychometric tests, if you want, but we prefer to say assessments, because tests would suggest that you can pass or fail, but assessments, while it infers, or it implies, yeah, that's a better word. It implies that you can pass or fail. You can't really pass or fail behavioral style assessment. Because it's more of a categorization based on your responses. Now, the field of personality, and remember I said that behavior is an element of personality. The field of personality has a really long history. We credit the Greeks with sort of the foundational elements of it. Some literature, however, points to ancient Mesopotamia. I'm not sure which one is correct, but it points to that part of the world even before the Greeks. Interestingly, there's a lot of historical literature that suggests that much of what the Greeks are credited with, they would have learned in that part of the world, Northern Africa. So, Kemet, Mesopotamia, those kinds of areas. In any event, the Greeks are credited with identifying these four elements and classifying them in terms of human behavior or as categories of human behavior. So, water, fire, earth, and air. A little bit later on, you had these psychological or personality type classifications of sanguine, melancholy, choleric, and phlegmatic. Those are still around, and if you look around in some textbooks, you still see references to these. A little bit later down, there was the classification according to these four fluids, or what was called the Greek humus theory. So blood, black bile, yellow bile, and phlegm. And then we had much later, now we have, and there were others, but I'm cherry picking some of the history here. Carl Gustav Jung, Jung looked at the emotions of normal people, and he looked at sort of why do people behave, normal people, quote unquote, behave the way they do. Extroversion, introversion, thinking, feeling, sensing, intuiting. And let me jump to number 6 on the slide. Myers and Briggs, a mother-daughter team, they actually picked up some of the research. And when I say picked up, sort of built on, not sort of, but built on a lot of the research of Jung, and created what is today known as the MBTI, or the Myers-Briggs Type Indicator, very popular personality assessment instrument. Marston created the DISC assessment, which is a behavioral style assessment: dominance, inducement, steadiness, compliance. And his work is in the public domain, so anyone can actually use Marston's work. And there have been many others since. We have the extended disc being created in the early 90s, building on the work of Marston. Right. So there have been many tools that have been created over the years. Of course, I don't have all of them listed here, but this goes back, as you can see, hundreds, possibly thousands of years. Because if we go back to ancient Kemet or Mesopotamia, Northern Africa, it certainly would have been long in advance of the Greeks and the numbers or the times we are seeing here. All right. So how is this science, this measurement, or this categorization, if you want, or assessment of human behavior? Well, a better question would be, what is science? Because for many of us, when we hear science, we think of the natural sciences, so chemistry, biology, and physics. But a far superior question is, what is science, or what is the scientific method? Right? Scientific method. So surely when we look at the natural world, science is quite useful. Natural sciences are quite useful. Chemistry, biology, physics, we're able to study many things and gain a better understanding of the world that we live in and the universe around us and that kind of thing. But scientific inquiry has a method. So it is an empirical or evidence-based method of acquiring knowledge, and that is credited to Sir Francis Bacon in the middle 1500s to the early 1600s. So if we say, what is science? We should elevate that question to, what is the scientific method? So when we talk about science, it's really a method of inquiry more than a discipline or an area of inquiry. So chemistry is an area or a discipline. So too is physics, but so too is psychology. It is it is the application of this scientific method, or this method of inquiry, this method, this empirical or evidence-based method of acquiring knowledge to a field of study. So let's push on a little bit. So the scientific method is a process for gathering information and processing it. So gathering data, processing information, and therefore it provides a well-defined set of steps to standardize how scientific knowledge is gathered through a logical, rational problem-solving approach or method. It is a standardized set of steps, which means that regardless of the field of study, chemistry, physics, psychology, anthropology, regardless of the field of study, the steps or the approach is, or the process is standardized, right? So the process of observing, asking questions, seeking answers through tests, data gathering, experiments, or so. It is a method of inquiry. So if you look on the right hand of this slide, you will see that the scientific method, this is the process. We make an observation. We see something in the outer world. We ask a question about it. We formulate a hypothesis, which is like your hunch. You say, I believe that this leads to that, or this is the cause of that. We make some kind of prediction based on the hypothesis. If the hypothesis is true, then X should be so or Y should not be so. We do an experiment or a test, or we do an experiment or we gather data to test the prediction to see if it's in fact the case. We analyze the results and then we say, okay, is this hypothesis correct or is it incorrect? Now, it's important to note you in PhD work, and I in scientific inquiry, maybe I should put it that way because I'm thinking as I stumble over this. In scientific inquiry, there's no requirement to be correct, meaning that your hypothesis must be proven to be true. There's no such requirement. You are making an inquiry. You analyze the results, you report those results. Now, you obviously can reform your hypothesis and gather more data and go again. But many times, certainly for PhD work, it is unusual that that would happen, especially in the social sciences. In the social sciences, we have a hypothesis, we gather data, we test the hypothesis. If the method of data gathering and analysis is solid, it's robust, we do good work, we report our findings, the issue of whether your hypothesis is proven to be true or false is not really the issue. It is really the method of inquiry and what you get out at the other end. And what you get out might just be to say, well, this is not so. This hypothesis was not proven to be correct. So the basic steps, let's go through it and then I'll go through an example. So we observe something, we define a question, we make a hypothesis. So the question is about what we observe. We make a hypothesis or a potential solution to the question. We test it, experiments, gather data, etc. And then with the results, if the hypothesis is true, then maybe we need to find more evidence or find counter evidence or come to a conclusion. If the hypothesis is false, we may need to have a new hypothesis, try again, or just conclude that the hypothesis was not proven to be true. All right? We can draw conclusions and repeat the scientific method. And you can do that in a never ending way, by the way, right? Because using the scientific method, no result is ever considered to be perfect. So it's interesting, even now as we are in the middle of this, well, I don't know what's the middle. We're dealing with COVID-19, and you hear people talk about the science as if it's this spot where you get to a destination and it's over. No, this is a never-ending process. There will always be new data. We could always test again, find new methods, test again, find new data, come to different conclusions, formulate new hypotheses, etc. So it's not the science as in a spot where you come to a conclusion and it's done. It's more an always evolving, uh, growing field of knowledge or body of knowledge. All right. So here's an example using the scientific method. So the observation is there's no water in the shower. We ask a question. Has the supply been disconnected? We formulate a hypothesis. If the supply has been disconnected, there will also be no water in the kitchen faucet or flowing through the kitchen faucet. Reasonable hypothesis, right? So we do an experiment. You turn on the kitchen faucet. So you go to the kitchen, turn on the faucet, and you realize the result, there is water in the kitchen faucet. That's your data. So we conclude there is no water in the shower, but there's water in the kitchen faucet, right? We refine the hypothesis. The supply line to the shower is broken, and therefore there is no water in the shower. Now, of course, you would need to gather more data. That would be go check the supply line. Hopefully, it's above ground, and you can see what has happened and see if this new hypothesis would be true or real. All right. Here's another one. So, observation is a real one. Countries with higher work ethic, according to the Global Competitiveness Index, tend to have a higher tend to have higher DISC scores in certain dimensions. Remember DISC from before: behavioral style, dominance, inducement, steadiness, and compliance. So if you look at the data, you will find that countries with higher work ethic seem to have or tend to have certain scores that are higher than those with lower work ethic. So the question is, does behavioral style affect or impact work ethic? Now you notice how we ask that question: does behavioral style, the DISC, impact work ethic? Because in this case, we would see behavioral style as the constant. So there are two variables we're working with. One is constant, right? One is constant, and the other one is a response variable, right? So the constant or the fixed one is behavioral style, because behavioral styles, we can't manipulate that. A person has a particular behavioral style, just like they have a particular personality, doesn't change very much over their lifetime. So that's taken as the constant or the fixed variable. And work ethic, which we assume can go up and down, is taken as the response variable, right? And so the hypothesis could be, if behavioral style affects work ethic, then work ethic will be uneven across the labor force, because behavioral styles are uneven across the labor force, right? So the research will be gather data on work ethic, gather data on behavioral style from a representative sample of the labor force, and examine the relationships. Two examinations could include correlation, multiple regression, and then we would have some kind of result, some kind of conclusion. Maybe we need to refine the hypothesis, maybe not. The reason you have question marks there is because, well, I haven't gotten to that as yet. Only getting ready to gather data, right? Because that's what I'm going to be looking at. This isn't actually my hypothesis. I have a few hypotheses. I think I have 7 or 8 of them, and I will do another video on hypotheses at a later date. All right. Okay. So in psychology, let's put those two together now: psychology and the scientific method. So, psychology was considered to be a social science because of the subjective nature of the things that are interested or interesting for psychologists. So, the factors of interest, they are social constructs. A construct is not something that exists in objective reality. It exists because we agree it exists. So it cannot be measured directly. So a good one would be somebody's work ethic. You can't measure a person's work ethic directly. It's a construct. You have to operationalize the construct in order to measure it. Meaning you have to look at what are the things that work ethic will produce, or what are the elements that if we wanted to measure work ethic, we would need to look for. So we might look at, I don't know, how many hours someone spends at work, how many days off from work they take. We could look at their production. How much do they produce in a given 8 hour day versus someone else? Those are just examples, right? But it's a construct. You can't measure it directly. Bullying is another one, another construct. And that it's a social construct. It doesn't exist in objective reality. We have built it. We have agreed on what it is. So because we agree, it exists. But it doesn't exist in objective reality. Again, if you wanted to measure something like bullying, what would you have to do? But you can't go and measure bullying. You would need to measure operational elements of bullying. So you would first need to operationalize the construct. So what would that mean? You would say, okay, the incidences of, let's say in schools, so children stealing or forcibly taking food, maybe money away from other children, hitting them, using obscene language, being violent, those kinds of things. You would need to measure those things, and then you would say, okay, if it's above this level, below that level, if I'm having these things, then I can say bullying is present. And the extent of it, well, you will have to have some scale to measure it, right? So psychologists often rely on observable observations, on behavioral observations, so things that we can see, and self-reported data. So if we apply the scientific method, it helps us to standardize the approach and ensure there is rigor, methodological rigor. It allows for retesting, validation, replication, confirmation. I'll come to validation in a short while, right? And this brings me to the point of science. I mean, if you think about it, we have all heard about scientific journals. Yeah. Think about scientific journals. Well, an example of a scientific journal is the Journal of Applied Behavioral Sciences. We call it JABS. That's published by Sage Publications and the NTL Institute for Applied Behavioral Sciences. Yeah. Now, NTL and Sage published the scientific journal JABS. It's a scientific journal. It's not about natural sciences. It's about social sciences, mostly individual group psychology and things of that nature, organizational psychology. So, is it science? Yes, because it's based on the scientific method. That's the critical thing. It's based on the scientific method. Right, and so that brings me to the issue of validity and reliability, typically of instruments, because you are measuring. You are using usually methods to gather information, to test, to measure, and they have to be both valid and reliable. So validity is the degree to which an instrument measures what it says it will measure, what it intends to measure. So it hits the target. That's validity. And then reliability is the extent to which the instrument consistently produces similar results over repeated measures. In other words, if under the same circumstances, the instrument should produce a similar output or a similar result. In order for us to use an instrument, a test, a tool for the scientific method or within the scientific method, it must be both valid and reliable. It has to be both. In other words, it has to hit the target and it must do so repeatedly under similar circumstances. So there are various types of validity. Face validity, which is the appearance, it appears to measure the construct. Content validity, so it sort of covers the extent of the construct. Concurrent validity, where it's correlated with other known measures. Yeah, correlated with other known measures. So if I'm building, for example, a new instrument to measure behavioral styles, I know there are other tools that we already have that accurately measures behavioral styles. So you should have some correlation between those two. Predictive validity, where it predicts some desired outcome. So we know that if we're using certain personality tools, um, for example, the five-factor model, we know that conscientiousness is positively correlated with productivity from years of research and many data sets. So if I build a new tool that is correlated or is similar to conscientiousness or measures something similar to conscientiousness, it should also predict productivity in a similar way, right? And then you have construct validity, which means that it fits the theory and the research. Now, the issue of validity is very, very critical. The issue of reliability is quite possibly really what the only thing that you need. And let me explain why. Let me go back to this page. So reliability means that it is hitting the target repeatedly, right? So it's not just hitting the target, but it's doing so repeatedly. And so most tools, most instruments use, or theorists, scientists, researchers will use Cronbach's coefficient of alpha, or it's also called alpha, Cronbach's alpha, and it is a statistical measure. It's computed by correlating the score for each item in a scale, for example, with the total score for each observation and then comparing that to the variance of all individual score items. Without going into the statistics of it, suffice it to say that a perfect Cronbach's coefficient of alpha is 1. And so for our research, our exploratory research, we use a cutoff point of 7, meaning 0.70, meaning anything under, let me say it positively, anything 0.70 and above is considered acceptable in terms of a level of reliability. All right? So if we look at this chart, we see alpha values, right? Cronbach's alpha values for a number of instruments. We have disk-based instruments, 0.85 to 0.92, eDisk or extended disk, 0.78 to 0.82. MBTI, you have 0.91, left of the point, to 0.92. Remember, we saw the MBTI and disk earlier. The FFM, which is called the five-factor model or the Big Five, and just now I made a reference to conscientiousness. That's one of the Big Five, right? So that's one of the things that this tool measures, and you would see it has an alpha value of 0.86 to 0.92. So all of these instruments have sufficient alpha values, meaning that they are rigorous enough. They are both valid and they're both valid and reliable for this kind of research. All right. I want to just go back here to clear something up. Let me just go back. Right. So you do have, in fact, instruments that are unreliable and invalid. We don't use those, we're not interested in them. There are those that are reliable, meaning that they will give you similar results over repeated measures, but they are invalid so that they don't hit the target. They're not actually measuring what they're supposed to measure. And then what we want, of course, are those that are both reliable and valid. They measure what they're supposed to measure, and under similar circumstances, they will do so repeatedly. So here's a good example of such an instrument in the natural sciences. A thermometer. A thermometer measures temperature. And that might be temperature of a body, temperature in a room, temperature in a space, whatever it is. We know once that instrument is working correctly and it's well calibrated, it will give us a similar measure, right? So let's say the seasons haven't changed. We measure today at 6 p.m. On a particular street, at a particular spot on that street, and the seasons haven't changed, the weather hasn't changed. We bring back the same thermometer tomorrow at 6 p.m. We measure again. We should get a similar value. Repeated measure, similar value, similar conditions. Same is true for a bathroom scale. Bathroom scale, once it's working correctly, calibrated correctly, will give you an accurate result repeatedly, right? So we want a tool that is both reliable, right? It would repeatedly give you accurate measures, and it would measure what it is supposed to measure. Now, the issue of validity for psychological instruments is a little bit different, because unlike something in the natural world, we are measuring human behavior in a lot of instances. So we rely on these various types of validity in order to be able to know that the tool fits our scientific method, right? So when you hear someone say, for example, they are a behavioral scientist, or they are looking at, or they are examining the science of human behavior, or they're a social scientist. You will hear that. That's probably the term you will hear the most. They are social scientists. They are correct. They are using a standardized method or process for gathering information, gathering data, processing that information, a standardized process that has well-defined steps for how knowledge is gathered. It is logical, it is rational. It is standardized. It is the same set of steps or similar set of steps that are used when we are measuring or when we are doing working in the natural sciences. It is the same set of steps. So science, someone does an MSc, for example, MSc, Master of Science. Usually that would be a specialized degree. That's a specialized degree. They use the scientific method. A PhD uses the scientific method, right? And that is what makes it science. It is not that it has to be natural sciences to be considered science. It has to use a process, a standardized process that the world accepts, that the communities accept, that process produces knowledge in a way that is both valid and reliable. We can rely on it. And most very important, and I know I said it earlier, someone can then go back, read that work that was done, and repeat that test, repeat that process, and they should get similar results. It has to be repeatable. So if you take up any scientific journal article and you read it, one of the things they do is they detail how they arrived where they arrived. That detailed information helps peers to be able to now say, this is good work. So if you are doing a PhD, as I am doing a PhD, my supervisors, my examiners, my markers, all those people who are involved, they are going to, with a fine-tooth comb, not just look at the results, that's important, but they are going to look at the process, the method that I used, the instruments that I used, how I came up with, how did I arrive at this way of generating or creating this knowledge. That is as important, if not more important than the method or the results themselves. That is what is going to be crucial. So when you read a journal article, and I know in an earlier video, I made the point that for me, scientific journal articles are the sort of the pinnacle of academic literature, because not only are they built according to the scientific method, but they are also peer reviewed, just like my work will be. And so this is one of the reasons why it takes so much time, because you have to be so methodological and so careful. It is painstaking work. All right, so I wanted to bring you this, look at this scientific method as how, in terms of how it applies in PhD studies. All right, so hope this was helpful to you, and give me some feedback. Let me know what you think. All right, again, this is Richard Solomon. Hope this was useful, and if you haven't subscribed already, please consider doing so. Take best care. Bye-bye.